Welcome to another Thinking Like LLMs lesson. I love these lessons because this is where we get to dive inside and look at some of the quirks about LLMs and figure out what is going on. And this one is called Big versus Small. And you'll see why it's called that in just a second. So I've hopped over into ChatGPT here, and I'm going to ask it a simple question. What's bigger, 9.9 or 9.11? And so if you think about this question for a second, you'll be able to figure it out pretty easily here, right? Well, 9.9 is obviously bigger than 9.11. It's a little bit misleading because the digits sort of mess us up here, right? So we've got 2 digits here after the decimal, 11, and we've only got 1 digit here. If I had 2 digits after both of them, then you can very clearly see here, okay, 9.90 is bigger than 9.11, right? That's quite simple grade school math. And it's also not unusual just to drop the 0 here because it's sort of an extra digit and we just don't need it. So even though it might seem a bit misleading for a second, if you think about it for a second, it's actually quite easy. And it's something that this incredible technology that ChatGPT is should be able to handle. Well, let's see what it says. And would you look at that? ChatGPT, this incredible technology, actually says that 9.11 is bigger than 9.9. And then it even gives reasons here. But it still comes to the wrong conclusion. It even recognizes, see, this whole thing about the extra decimal place. And it still says, comparing digit by digit, you see that 9.90 is less than 9.11 because 90 hundredths is less than 110 hundredths. That's wrong. I see what it's done here, actually. It actually is adding another 0 to this, too. So it's actually saying 90 is less than 110. But that's just incorrect. It has hallucinated this response. And I actually love that it gave this reasoning here because if you just quickly looked over it, you might think it's accurate. Oh, okay, it reasoned through the actual answer. And so you say, okay, that's the answer. And this is a great example of a hallucination that you might fall for if you're not actually paying attention. So that's interesting, right? Now, why do you think it got this question wrong? Pause the video for a moment, think about it, and then come back when you're ready. Okay, welcome back. What did you think? Why did you think that it got this answer wrong? It's a simple question, right? Well, here's where this is gonna get fun. We are going to use a tool to dive inside the mind of an LLM and figure out why it is hallucinating this answer. So here we have this tool called the Model Investigator, which is by a company called Transluce. And this company is all about researching mechanistic interpretability. That's something we've mentioned before, and we'll talk about it later on as well. But in short, it's all about understanding and interpreting how and why these models give the responses that they do. Because they are a black box in a lot of ways, right? And mechanistic interpretability is all about trying to help us understand what's going on inside that black box. And this tool, the Model Investigator, actually allows us to poke around and see why the model is generating certain responses, including this hallucination. So I'd encourage you to actually go to this URL right now and follow along with this lesson. So here's what we're going to do. We're going to click this button that says Fix AI's belief that 9.9 is less than 9.11. Okay, So this over here is the investigator, and here we've opened up on the left a chat with this model, all right? This is not the same as the ChatGPT model, but it's actually interesting that it gives the same response. So unfortunately, for some reason, it highlights this token. This seems to be a bug. I'm just going to click that to clear the dot, and then I'm going to click that X too. Okay, ignore what's going on over here for now. And instead, let's focus on understanding what's going on the left here first. So here we just have a normal input-output chat with a model. You can see the prompt, the input is right here. Which is bigger, 9.9 or 9.11? And you can ignore these other characters here. These are just special tokens, but they're not relevant for our purposes. And then you can see the model's response here. The model hallucinates and says 9.11 is bigger than 9.9. As we just saw, that is wrong, right? So let's put our investigator hat on and figure out what's going on here. Well, which of these tokens do you think is incorrect, has led to the hallucination? I'd say this is probably the best place to investigate, right? This bigger token, because it should say 9.11 is smaller than 9.9. But as you can see in the top left, it actually shows the probabilities here. And bigger has a 96% chance of being selected. So, and look at the other token options too. There's not even a choice for smaller. So it wasn't even close to selecting a token that said 9.11 is smaller than 9.9. So what we're going to do is we're going to click on this bigger token and investigate it. So we click that, and then you can see here, the text appears that says, find neurons influencing the prediction of space bigger, because that's the actual token, okay? And so what the investigator is doing here is it's actually looking inside the model and figuring out which neurons or clusters of neurons most influenced the selection of this token. Or in other words, what neurons caused the model to select this token. Now, it's not clear. It's not always clear cut because there's so many neurons inside these models, billions. And so it's not like one neuron leads to the selection of this bigger token. Instead, there's clusters, and they all contribute to the model selecting a token to different degrees. So it's not a one-to-one comparison, but we can still investigate. So here we go. It seems to have had an error here, but that's okay. We'll focus on this bottom one. And so it says, I found some neurons that highly influenced your selection. That is the bigger token. I grouped their behaviors into these clusters. So look at this. It found these different neurons. You can see 6 neurons, 9 neurons, and 4 neurons. It found that these neurons, which are clustered together into 3 different categories, seem to have most influenced the model's prediction of the token bigger here. And these neurons can be categorized into 3 different clusters. One has to do with the September 11th terrorist attack. Another has to do with months, dates, and years, and calendar references. And the last has to do with biblical chapter and verse numbers. And I just want to make it very clear what's happening here. It's saying that there are 6 neurons here, and those 6 neurons normally fire when the September 11th terrorist attacks are mentioned or major historical events are mentioned. These 9 neurons often fire when dealing with months, dates, and years. And these 4 neurons often fire when biblical chapter and verse numbers are referenced. Okay, so these neurons generally fire when those concepts are mentioned in a prompt, but they don't only fire when those concepts are mentioned in a prompt, right? Like I said, all sorts of neurons are firing in these models with every prompt. And for whatever reason, the simple prompt of which is bigger, 9.9 or 9.11, caused these neurons to fire. So this is starting to make a little bit of sense, right? One of those clusters has to do with dates. And if you were to show 9.9 or 9.11 in date form, 9.9 would be less than 9.11 because the first digit represents the month and the second digit represents the day. So September 9th is less than September 11th. And similarly with Bible verses. The first number represents the chapter and the second number represents the verse. So chapter 9, verse 9 is less than, it occurs sooner in the Bible than chapter 9, verse 11. Okay, so maybe we're starting to put together the pieces here a bit. It seems that the model is giving the incorrect response. It's hallucinating here because it's associating these numbers, at least in part, with dates and biblical verses, right? And then the 9/11 terrorist attack is also coming into play here because that is, of course, a date. Now, we can actually click into these clusters. And this brings up a list. And this list shows you the high influence neurons. That is, the neurons that are having a big influence on the prediction of the token bigger. And that is how the model investigator came up with these 3 different clusters. It looked at the neurons and said, oh, there's a commonality here. A handful of these neurons, 6 in fact, generally fire when we're talking about the 9/11 terrorist attacks or major historical events. Another 9 neurons fire when we're talking about dates, things like that. And you can see the ones in each cluster are highlighted in green. So these green ones here are the 9/11 terrorist attack neurons. If I click the date cluster, then it highlights the neurons associated with that cluster, with dates. And so you can see here, this is the actual neuron ID. And then this is a quantification of how much that neuron attributed to the selection of the bigger token. So you can see the neurons are actually ranked here from most to least. So that is pretty cool, right? We've investigated and we've come up with a pretty good hypothesis for why this model is hallucinating in respect of this specific prompt. But you know what would be even cooler? If we could test this hypothesis, right? Oh man, that would be cool. Well, hold on to your shorts, because that's exactly what we're gonna do right now. You can see below this cluster here, inside the investigator, it has a show me button. So we're gonna click that. And it's gonna give us these options now. So it is gonna actually let us suppress the neurons associated with biblical verses. And we can also suppress the neurons associated with months and dates. Now, what do I mean by suppress? Well, we can actually see here. We're gonna click this, and here we go. We're gonna actually be able to select the neurons that we want to steer the model with. By steer, we mean we're going to influence its prediction of the next token. And we are going to suppress it, but you could strengthen it as well. But we want to suppress it, meaning set its activation to 0. So we saw this before, how neurons fire, right? And that influences neurons in the next layer and the next layer. We're going to make it so the activation of this neuron is 0. So the neuron is not going to fire. And in fact, we're not actually going to just set the activation to 0 for one neuron. We're going to set it for 500 neurons that are associated with this concept of biblical verses. Okay, and you can actually see the list of neurons right here. Each individual neuron, and it tells you about what that neuron is generally associated with, right? You can see this neuron right here is associated with the token Bible. This one is associated with the word verse, but not just in the context of Bibles, but also in terms of literary, musical, or scriptural references. So you can check these out if you want, but right now, our focus is to test to see if it's actually these neurons that are causing the model to hallucinate. So we've got our concept, we've got the number of neurons. You can change this between 1 and 1,000. This is the number of neurons that we're actually going to either suppress or strengthen. In our case, we want to suppress it to 0, and then we're going to leave this field as it is. And all right, this is the button we're going to click once we're ready to test our hypothesis. What it's going to do is it's going to suppress all these 500 neurons, and then it's going to resend our prompt asking the model which is bigger, 9.9 or 9.11. So 3, 2, 1, let's go. And okay, it's resent the prompt to this model. Here we go, which is bigger, 9.9 or 9.11? And what's the answer? 9.11 is bigger than 9.9. That is still wrong. Even after suppressing 500 neurons, putting their activation to 0, it still gets the answer wrong. Is that surprising to you? I think it's a little bit surprising to me, but I think it does a good job of showing both the importance and the infancy of mechanistic interpretability, because these models are just so complicated. What's going on inside them is so nuanced that even suppressing 500 neurons on a concept that we really think is misleading our model still doesn't solve the hallucination. However, have no fear, because we can also suppress the neurons associated with months and dates. So let's see if that helps our hallucination problem. All right, here we are again. We've got the concept of months and dates. We're going to suppress 500 neurons, and here we are. We're going to suppress them, not strengthen them. You can see the neurons over here. We've got a neuron that has to do with months of the year. We've got a neuron to do with dates in various contexts. We've got instances of hours or months, and lots more. All right, let's steer these neurons. And here we go. Ta-da! Look at this. Our prompt was resent, which is bigger, 9.9 or 9.11, and the response is 9.9 is bigger than 9.11. Hooray! We got the right answer, finally. The model no longer hallucinated. We had to suppress 500 neurons with the biblical verses and 500 neurons with months and dates. But we finally did it. And that appears to experimentally confirm our hypothesis that the numbering systems associated with biblical verses and months and dates caused the hallucination in ChatGPT. How cool is that? Now, don't close this browser with the model investigator, because in the next lesson, I'm going to have you be a bit of a mechanistic interpretability researcher yourself. I'll see you there.